The yield keyword in C# can be a confusing one. So in this video, we're going to go over what yield is, how it works, and how to best take advantage of it in our code. Now, if this is the first time you've viewed a video on my channel, my name is Tim Corey, and it's my goal to make learning C# easier. I have hundreds of videos on this channel around C# and the related topics that will probably be helpful to you, as well as videos on just how to be a developer in general and answering those questions in my Dev Questions series. I also have a site where I sell full courses on IamTimCorey.com, where I have dozens of courses that will be really relevant to you as well as if you're a C# developer. Check out all the resources I have. There's links in the description for everything. Also in the description, you're going to find a link to the source code for today's video. What I do is I package up all the source code, I put in a zip file, I put a link in the description, you fill out a form, and I'll email you that source code. Okay, so check that out if you want to get the source code. I think that's it. Let's go ahead and get started with Visual Studio. Now, we're going to create a new project that is a console application. Just something really simple. We want to get past all the UI stuff. We don't want to care about that. We want to focus just on the yield keyword and what it is. So let's start by getting our setup out of the way. So this is our yield demo app. So I'll say yield demo and yield demo app. We'll hit .NET 5, which is the current version as of the creation of this video, and we'll go create. So this sets up for us our basic starting point, which is the console application, really simple. Okay, so that way we can kind of not focus on this. Now, the yield keyword, let's talk about what it does first in abstract or theoretical terms, and then let's see it in action. So in theory, what yield does is it allows us to call a method multiple times and have it run for a little bit and then pause and wait for the next call. Basically keep a stateful spot in the code. Kind of put its thumb in the index and say, hey, okay, wait right there until the next call. Okay, let's flip, a few more pages, put the thumb in, and so on. That's really, theoretical. It's a little weird. So let's see this in action. Just see how this might work. Okay, let's first start by getting rid of our sample code. I'm going to put a couple of lines in here. So console write line, CW tab to create a snippet. And we're just going to say start of the app. And then I'll do another one down here. Again, CW tab. And we're going to say end of the app. That just gives us some bookends to see, okay, the app started, the app ended. And we're going to use these entries as kind of a way to give us an indication of, okay, this is how the flow of the application is going. That's all it's going to do. Now, let's create another class. I'll do it in this same file. We'll move it off to its own file in a minute. We're going to say public class person model. And I hit Shift Enter to get those curly braces put in. If you haven't seen the video I did on the recent 10 tips to make Visual Studio faster or make you faster in Visual Studio, go check that out a couple of videos ago where I covered things like that smart enter or smart line break. So in here, we're going to say I want a first name and a last name. Nothing too complex, really simple, basic demo model, okay? That's all this class is going to be. And we're going to create a constructor out of this. So let's do our control dot and say generate constructor. Again, that's in the same video I talked about just a minute ago. And that creates our constructor for us that fills in the first and last name based upon the parameters being passed in. I'm also going to add one more thing, a console write line in here that says initialize user. I need to put a $sign in front of this for string interpolation, because we'll say first name space last name, like so. That just lets us know, hey, you created the person model, okay? And which person model was it? Well, here's the first and last names you passed in, just so we know which model it was. Okay, that's our simple demo person model. I'm going to move that off into its own file. Okay, so now we got the person model class. Okay, now we're getting ready to create our demo for what Yield improves upon. So let's create another class in here. Public class, let's call this data access. That's what it's going to simulate. And then in here, I'm going to say public IEnumerable control dot to add that using statement. And person model. And actually, I think I add the wrong using statement. It's dot generic. There we go. And we'll call this get people. Okay, that's our really simple method that it's going to simulate data access, but it's not actually data access because we're not actually going to go a database. We're just going to create 3 sample users. Okay, so we'll say a list of person model, output equals new, like so. And then I'll say output dot add new person model. And we'll pass in Tim and Corey. All right, and we'll do this a couple more times. Now I duplicate this a couple more times. I'm going to say Control C, Control V without anything highlighted, and it's going to add 2 more entries for me in line to duplicate those. Now for this, let's say Sue Storm and Jane Smith. Okay, and we're going to say return output. Okay, that's a simple get people method. In fact, it's so simple that it's not storing anything in this class. So let's make it static. That way we don't need to actually create an instance of data access in order to use it. So up here, we might say something like var people equals data access dot get people, right? And then we could do a for each on this, for each p in people, like so, and we'll say console write line, and then let's just say our string interpolation here. We'll say red, and then say our p dot first name. I have to put spaces around my things, but you don't have to. P dot last name. Okay, so this just says, okay, get the people, and then print out that you've read them. Okay, real simple stuff, just to have a demo to start from. Okay, let's run this and see the output. All right, so we have the start of the app. We initialize the user Tim Corey. We initialize Sue Storm. We initialize Jane Smith. We read Tim Corey. We read Sue Storm. We read Jane Smith. And then we ended the app. That's the traditional way we normally think of building up our objects and then iterating through them and reading them. Now, what this has done is in this section right here, we created all of our objects. We put them all into memory. We then transmitted that, which was just, hey, here's a pointer to that same spot or a reference to that same list. But we transmitted all those over to the calling method, which then read or processed all of them. In the context of a database, maybe we have a list of all the users in address book. Let's just say there's 1,000 of them. We would create 1,000 user objects, and then we would work on those 1,000 user objects, okay? That's the standard way we think about doing things. But this loads all of these in memory up front. And then we do work on them later, but only after everything is in memory. What Yield does is it says, maybe there's a better way of doing this. Maybe you don't need all 3 of those users. Or maybe you do, but not all at once. Maybe you need just the first one right up front, but maybe you're going to wait 5 minutes and then ask for the next one. Or maybe we're not sure how many we're going to iterate through, so why are we creating all of them up front if you aren't going to iterate through any of them. So yield says we can do things differently. Instead of doing all of our initialization up front, we will create the users as you need them and not before. So let's see how that would work in this code. So let's change over our data access code. Now I do want to say right up front that yes, this is a very contrived, simple example at first. I'm going to walk you through how to use this in the real world, but I want to show you the very simplest I could of yield. So instead of having this output variable, don't need it. Instead of having the output.add, of course, that goes away as well. Let's get rid of those. And we don't need this return down here. And we don't need that end parentheses because we're just newing up 3 different items. In front of all of these, I'm going to say yield return. And you may say, wait, Tim, you can't have 3 return statements in 3 lines. Yes, you can if you put yield in front of it. So what's going to happen is because we say yield return, when we call for the first user, it will run this line only, and then it will wait. And then the next time we call for a user, it's going to return this line. And the third time, it will return this line. And after that, it's going to say, I don't have any more. So it kind of pauses your code midstream. Now notice this is not asynchronous. You can have async enumerable that returns, but in general, we don't need that unless we're going to be calling asynchronous code inside of this method. So IEnumerable is fine. And yes, it's IEnumerable, not IList or list. And the reason why is because IEnumerable handles the idea of the list, or the set of items, let's put it that way, not list. The set of items is not necessarily always complete. We use IEnumerable with Entity Framework because we can do work on a set before we actually do the query. Well, in the same way, we're going to be able to look at this set before it's complete. So I haven't changed anything else. I just changed this code right here to say yield return in 3 spots. This code has not changed in the least. Let me run this same code. It all ran, but notice the order is a little bit different. We have initialize user Tim Corey and then read Tim Corey. But then we have initialize Sue Storm and read Sue Storm. Initialize Jane Smith and then read Jane Smith and then end of app. So the application does all the same work, but the ordering is different. That's because what has happened is when we say get people, let's actually put a breakpoint right afterwards and run this. Okay, so we're at the breakpoint. We have run this line of code, but not yet the for each. So let's look at that people list. Let's go to our locals window, which is very small. I'm going to zoom in here on it. All right, so this is the people list results view error. We don't have a results view. Notice there's no count. It just says current. That's all it says in there for there is no current selector yet. Okay, so it's a really different set than we're used to. It's not like list. Instead, it actually hasn't even called this code yet. In fact, let's put a breakpoint right here at the first line, which hasn't been called yet. And I'll prove that in just a minute when we run this people. Let's continue running right where we're at. Actually, no, let's skip over. So we're going to step into this list. And notice that we've now said var p and people, and it goes, oh, I need to call this get people list. And it says, okay, let's yield return. And it's going to create that person. So it populates. That's an automatic step over, that's fine. It populates the items. It's going to spit out that, yes, I initialized Tim Corey. And then it's going to come back here. It's going to go back to the in. and it's going to populate this P variable, which currently is null. It's a little small to see, but it's null. And now P actually has, let's zoom in here, it has a person model with Tim Corey in it. All right, so let's put our breakpoints down here just so you can see what's happening. Oops, come on. There we go. I put a breakpoint each line now. So now we're going to step into this. It's going to print out to the console. We're going to go to the next for each and say, okay, the end's going to run now, which means we're going to run the next to the next yield return statement, which is going to create SueStorm. Now SueStorm has been created or initialized. Now we can go and populate P with SueStorm. And now the first name here will be Sue and the last name will be Storm, and it can print that off. And it's going to keep going this way until after the last yield return. So you run this, it's going to be the last yield return, and after that, so it's going to populate the last person. It's going to then populate P. It's going to go to the right line. We're going to come back up here and say, okay, I want you to keep going. So we're going to keep going. We get down to this curly brace at the end here where it says, hey, I'm done. So it completes this code. And then it goes, yeah, I can't populate that P. Therefore, we're done the for each. We go to the end of the application. That's the yield keyword in a nutshell. Now, I'm going to give you a more concrete example of when you actually use this, but I want to show you at least one more trick before we're done with this simple example. So why would you care to have a yield return? Now, this is obviously contrived. We would have some kind of code to generate or pull the information from somewhere, not just have 3 yield returns that return 3 sample pieces of data. But why would you do something like this? Well, why would you not just return all of them all at once? It seems simpler. And in fact, just so you know, this yield return does add a little bit of overhead onto our call. Essentially keeping a bookmark in a method saying, okay, I'm going to hold on to that state and wait until you call again, that takes a little bit of memory. So this isn't a free thing we're doing. We're actually making it a little more expensive. And if we're going to return the same amount of items, it doesn't really make sense. But think for a minute, what if I didn't do a for each here? What if I only wanted a few people, or maybe even just one person? Why would I want 3 people returned to only use one of them? It'd be more efficient to just return 1. Well, we can actually do that using link. You say .take, which have to add the using system.link. Take and say, you know what, I want to take 2. Now, if you're familiar with this method, probably you've used Entity Framework before. Entity Framework uses this, but this concept here is that, yeah, I want to get people, but I only want 2 of them. Not 3, just 2. I have no clue how many it will return, but I'm only going to use 2 of them. Well, guess what's going to happen when we do this? Remember that we can make this call. It hasn't pre-populated this IEnumerable. It's just said, okay, we're ready to run this once you say go ahead. We haven't done anything more than that. So I say take 2. I can add that to my IEnumerable where it's going to go, okay, gotcha. You only want 2, therefore I'm not going to give you more than 2. So this people now maxes out at 2 entries, even though I have 3 yield returns. Let's see what happens if I just run this. I initialized Tim Corey and I read Tim Corey. I initialized SueStorm, I read SueStorm, and then I ended the app. What that means is by just adding this little thing right here, take 2, I have eliminated the creation of a full object that wasn't necessary. This is the benefit of yield. because I can say, I don't want 100 things, I want 3. And it will only load 3 into memory. So let's see this in a bit more concrete detail. So let's move data access. We're going to do control dot and move to data access.cs so you have it for later. And I am going to comment out this data access demo. Okay? We're going to do a new demo. Now in this demo, we're going to create a new class for this. Public class, let's call it generators. And in here, let's create one public static IEnumerable. Control dot to add that using collections.generic. Notice that it's gone because I actually moved that over with my data access class. So IEnumerable of type int. We're going to call it as get prime numbers. This is a fun little method. What we're going to do is we're going to get prime numbers. Now, you may say, well, which prime numbers? How many prime numbers? We're not asking for any of that information. In fact, we're going to get prime numbers unlimited. We're going to get unlimited prime numbers. We're not going to limit how many we can get, which, of course, normally would cause a Stack Overflow exception. It won't for us, though. Now, in here, I create a method that finds one or tests for one prime number. Private static bool is prime number int value. Now, this prime number check isn't going to be the most efficient check ever. It's not horrible, but it's not extremely efficient, which is what you'd want for a prime number checker that's going to be going into the tens of thousands. But for our purposes, this is perfect. Okay, so just want to have that disclaimer. So bool output equals true. And then for I equals 2, it will be I equals 2. I is less than value divided by 2. And we got to start with 2 here. Okay, and then in here, if value modulus I equals 0. If you're not familiar, what this does, this percent sign here, it's going to divide value by this number. And if it divides evenly, it'll be 0. Okay, if it doesn't divide evenly, it's going to return the remainder. So in here, output equals false because it divided by 0, it gets 0 as the result of this test. That means it has divided evenly. Therefore, it is not a prime number. That's what the false is for. And we don't need to check any further, so we can just go ahead and hit break. That's going to break out of the for loop. And then we will return output. So what it does is it's going to loop through all the numbers starting at 2, going to half of the value, and we're going to check to see if any of them divide evenly. Okay, that's, if you want to go more deep into prime number theory, that's a topic for another day. But this at least gives us a prime number checker. All right. Now in our get prime numbers, I'm going to write code that without yield, you should never write. All right. Int counter equals 1. While, this is the kicker right here, true. If is prime number counter, yield return counter. And then down here, counter plus plus. Now, why should you never write this without a yield? Well, because the while true, this is going to run continually, forever. It will not stop. Meaning you get a Stack Overflow out of memory exception, you'd have a problem because you would run out of either integers or you'd run out of memory to hold all the stuff you're doing. So this would be a problem. But because we have a yield return, what's going to happen is it's going to say, okay, return that value and wait to see if I'm called again. This means we can run this safely as much as we want. Now, we can't just say for each and let it run forever, because yes, that would still cause the same problem we are talking about earlier. But we can let it run for as long as we want. So let's come up here now to our code. I'm going to say var prime numbers equals generators dot get prime numbers. Notice I'm not passing in any other type of modifier there. So this IEnumerable of type int, which I'm saying var here just because I don't want to type it out again. That's an IEnumerable of type int. I'm just saying get the whole list, which again, if we didn't have yield return, would be a major problem. But it's not. It's fine. Now I can say for each var prime in prime numbers, console write line, let's just write out the prime itself. No reason to go further than that, okay? Now, remember I said that, yeah, you still want to limit this in some way, but we've learned how to do that with take two. So let's take, I don't know. Let's start with 10,000, okay? And let's run this. You might say, man, 10,000 seems crazy. It's already printed out. Okay. In fact, in my testing, I found it actually takes longer to print out the numbers than it does to run this. So it's pretty crazy. But notice that the top prime number here is 717, sorry. So this has gone through and found for us 10,000 prime numbers. But what it didn't do is run forever. It still had an end. It's just that we told it when to end, which means it didn't generate 20,000, 30,000, 50,000 prime numbers. It generated just 10,000. Let's get even crazier and say, you know what? I want to have 10 prime numbers with the same method that I just ran before. There's those 10 prime numbers. It only generated 10 prime numbers. It did not generate an 11th or a 12th or 10,000 of them like we just asked for. It just generated 10. So we have not used the memory to look for 10,000 or 100,000. We've used the memory to look for 10. And this is where the yield keyword becomes so very powerful in specific situations, not for every situation. But with this, I can allow the user to generate as many prime numbers as they want, because they're not going to say unlimited. They're going to have to say, yes, I want more. I could potentially say, you know what, generate 10, let's generate 10 more. Let's generate 10 more, 10 more. And they have to say, give me more, give me more, give me more. It's got a flashback to a Grease song. But they only generate 10 at a time. They're not generating all of them up front and then only using 10. So that's where the yield keyword can be really helpful. So one of the ways this can be helpful is, let's say you have a database that has one table in it that has 1 million records. Maybe it's your master customer list. And you have a page that is going to show all the customers in your database. Well, you can't do that. 1 million records, it's just not feasible to load that many records into memory, especially since the user isn't going to look through all 1 million. Even worse, let's say that once you download the records from a database to your application, you have to do some work to rehydrate the model. Maybe you do some subsequent calls to the database, or you do some calculations in order to get things like account balances and so on for each user. Well, that'd be very expensive to show 1 million people when the user wanted to see one, or just the first page. Or if it's help tickets, you don't necessarily want to see every help ticket in the database. You just want to see the one to deal with next, the one at the top of the list probably. So it doesn't make a whole lot of sense to have every item in that data grid. You just want to show the first page of it, which we're used to doing paging operations. But this way, you could do a paging operation where you pulled the first set from a database, you rehydrated and did your work on even a 10th of those, showed that 10th. When they said, give me the next page, you just rehydrate the next 10th until you get to the end. And then you say, okay, I still need more. So I'm going to go back to the database and get the next set and hydrate a 10th of them and send them on to the user. You can use this in concert with your paging to really hone in on just what you need to do in memory. Yield is incredibly powerful at allowing you to not know how much you need until you need it. So we could be doing this work right here could be done at runtime, where I say take 10. Now notice, let me show you this. If I said waiting for user input, like so, and then let's just do a console read line, like so, and then afterwards, I'm going to do this exact same code. Actually, let's just do like this. Okay, we're gonna get 10 more. Actually, let's make it 15 just so it's clear that it's different. Okay, so I wait for the user input and then I'm gonna do some more. So let's run this. We've got the first 10 of them. I hit enter. Now I get a next set. Now, since I called again for the next set, it starts over from the beginning, which is like, okay, well, that's not really holding its place. You're correct, because I did the 10 and I said only give me 10. So I'm gonna restart on the next call and say, okay, now just give me 15. But if I, instead of doing this way, if I change this, let's change this code right here. Let's do it a for loop and said for I 0 less than 10. And then what we're gonna do is we'll get the next prime number. But here's the question, how do you iterate over an IEnumerable? Because if we knew its bounds, we could say something like, prime number at position I. But that won't work for what we're doing here. So this is where it gets a little bit more tricky, but I did want to show you this because it's an interesting, at least thought experiment on how to do this. So what we need to do is we need to create an iterator. So var iterator, like so, iterator, there you go, equals prime numbers dot get enumerator. What this will do is it will get us something we can enumerate over. Enumeration means put numbers to. So we're going to iterate over this and use this to identify, in this case, the next 10. So for I equals 0, I is less than 10. We're not going to care about I, we just need to count from 0 to 9, or have 10 of them. We're going to say if iterator dot move next. Well, I'm going to write this quickly here. That's what comes from an iterator when it's iterator. There we go. Iterator.move next. What it's going to do is, notice it's going to wrap in an if statement here. It's going to say, okay, can we move next? And if we can, let's go ahead and do that. Now, since this is the very first time we run this, it's going to move next, which really goes to the first one. But we'll see that when it prints out. It should print out number 1. Now, the move next, if it succeeds, we're going to say console write line. And in here, we can say iterator dot current. They see the current number that's on. Since we've moved next, that current number should be the number we're looking for. Print that out since it did find it. Else, And here what we're going to say is just break, meaning we can't do any more in the for loop because we're done. There is no more ability to move next. So this gives us our first 10. We can comment this out because we're not going to use the for each. They're going to wait, but instead of getting more, we can get rid of this line right here. And we can run this same code down here. Notice I didn't grab the iterator again. We're going to use the same iterator. And we're going to take off this take 10. So now it's going to get unlimited number of prime numbers, but we're only going to iterate over it 10 here, and we'll do 15 here, just to show we can. And we'll move next and iterate over them. Let's run this and see what happens. We have number 1, start with number 1, great. 1 through 19, that's the first 10 prime numbers. Hit enter. Now we have 23 through 83. That's the next 15 prime numbers, and we're done. This is how we could use our application to say, okay, user, you want the first 10? Cool. I'll give you the first 10. And you say, oh, I want more? Cool. I'll get more for you and more for you forever, potentially. So I want to show off you can ask for it more than once if you set it up properly. If you go back and redo the call, that will restart that operation, which is why the for each, we had 2 different calls to the same method does the yield, didn't work the way you'd first expect it to. Okay, so that's how to do that. But what if we decide we want to have a list? Because everybody likes lists, right? I love the list. So let's do this. Let's comment out. Well, actually, let's just comment out this one down here. So we just have this commented out. I'll leave it for you for later. We're going to loop through just 10. But just for safety's sake, what I'm going to do is actually, I'm going to comment this out as well. And we're going to go back to our for each. All right, which does mean we have to limit this. And that there's an important point for this. So take, not the enumerator, that should be commented out as well. No need for that. We're going to say dot take, and let's take 30,000. That's a lot of prime numbers. And when you run this app on your computer, it may not run at the same speed mine does. So you may want to lower that number. But I know that mine doesn't take a ton of time with this, but it does take a little bit of time. Okay. I've asked for 30,000. Then we're going to loop over it. All right. And we're going to run this. And it's already scrolling. I mean, it's already going. It'll take a little bit, but it's going to print off all 30,000 prime numbers. Note, we're not going to reach the number 30,000. We've already exceeded that by far. We're going to print out 30,000 prime numbers, and they get further and further apart as you go higher in the numbers. So it's 350,347 is our top prime number. So, but you saw how that ran, and actually the printing off the console is a very expensive process, which is why it took as long as it did. But I want to show you something. Let's just say you go, cool, I like this, but I really want to list. I want to generate a list of these so I can work with the list keyword and have all the extras that list provides. This is a mistake when dealing with yield. I'm going to show you why. Let's run this app again. Notice it says start of the app and nothing seems to happen. It's sitting there and waiting and waiting and waiting. What's happening? Well, what happened is it actually generated all of those values and then started printing them. So it generated up through prime number 350,347 before it printed number 1. Because the to list, what it does is it says, in order to be able to do all the cool stuff list does, I need to know things like the count. So I have to populate this entire IEnumerable with all 30,000 elements before I go on to this line right here. So keep that in mind when dealing with yield. is that when you say toList on your IEnumerable, it immediately calls everything. So if I didn't have a take 30,000 here, this would do a toList on get prime numbers, which remember, get prime numbers has no end, which means it's going to try and get a list of every possible prime number to the end of the universe, which is going to obviously stop before then. Not that your computer will tell you that, because your computer's going to crash at some point. It's going to say, I'm either out of memory or I've reached the end of int 32, which is a big number. So either way, you're going to have a problem. So you do not want to use toList on your IEnumerable. It's the same reason why you don't return a list of int, you return IEnumerable. So just keep that in mind. And if you're thinking, hey, I've done some of this link stuff with Entity Framework and I use toList all the time, that's a problem, because the IEnumerable allows you to do work on it before you do the query. Once you say toList, you have gone to the database and done the query, and then anything after that is done in memory. And that can be a very expensive process. So be careful where you put this toList, if anywhere, in your Entity Framework calls, okay? So that's just a bonus tip there. So this is the yield keyword. Yes, it does have limitations. Yes, it's not something you'll use every day, but when you find the occasion where you say, hey, maybe it's get prime numbers, the example you're going to use, but whatever it is, where you say, you know what, I need to do some work and it's expensive work, but I don't know how many times I'm going to need it, how many times the user's actually going to want me to do that work. Yield can be a really powerful solution in your toolbox where you say, you know what, I don't care. As many times the user wants to do it, we're going to do that, and we'll just use the yield keyword to not do the work until they request it. That way, we're only doing just enough to satisfy the user and no more. This can make for a very efficient program, and it more than makes up for the little extra overhead that yield adds when you're dealing with that placeholder, that bookmark that it's holding on to. Okay, so that's the yield keyword. I'll give you this source code, the link's down in the description below. Check it out, try it out. Definitely practice this, because it takes a little bit to make sure you get your brain wrapped around what it's doing, why it's doing it. Use the breakpoints like I did. Walk through it. Be careful on not limiting. I would encourage you to first start using yield. Just limit things. Even if you think that's way beyond what you'll ever use, put a limit on it. That way, if you accidentally have toList, you don't blow things up and cause massive problems. But just try us out. Get your hands dirty with this. Create a few practice projects that mimic what I did or close to it with a few different tweaks. Try it out with databases. Try it out with other expensive operations that you do, and just make sure you understand how it works so that when it comes time to use it in production, you already have experience in it. All right. Let me know if you have any questions down in the comments. Let me know if you have used yield in any way in your production code. I'd love to hear about it. Thanks for watching. And as always, I am Tim Corey.